Knowing the change of base rule is going to help you type problems into your calculator. So let's take a look at something that you can't do in your head, like 3 to what power is equal to 15. Now we know that's actually somewhat bigger than 3 cubed. Sorry, bigger than 3 squared, smaller than 3 cubed. So it'll be between 2 and 3. And if you wrote it as an exponent, you'd have 3 to what power equals 15. At which point, one way to solve exponential equations is to log both sides. So I could take log of 3 to the x equals log of 15, and then use the power rule, so the x here comes out front, and I end up with x log 3 equals log 15. And now I divide both sides by the log of 3, and I get the log of 15 divided by the log of x, log of 3. Now, that's actually a lot of work, so you could jump straight from the question to the answer by knowing the change of base rule, which says if you want to evaluate this first problem, log base 3 of 15, you just take the log of 15, so the 15 goes on top, divided by the log of 3, the 3 goes on the bottom. And you can check this out in your calculator. It wouldn't actually matter if you did the log or the natural log. Change of base rule works for any base. You could evaluate this as ln 15 divided by ln 3 and get the same answer. I'll let you take the time to verify those are the same on your calculator. The general rule for solving log and exponential equations is to condense, isolate, convert. Let's look at a problem that involves isolating. So let's say I had e to the 2x minus 1 plus 5 equals 8. Okay, this problem doesn't use any condensing, but I do need to isolate the e before I get started, and I'm going to do that by subtracting 5 from both sides. So I have e to the 2x minus 1 equals 3. So now that I have this isolated, I'm going to convert this exponential function into a log. And this is going to be a log with a base of e, and as soon as I realize the log has a base of e, I'm going to write it as ln. So this is ln of 3 equals 2x minus 1. Remember, the logs are always equal to exponents, so the exponent goes after the equal sign. And now you're going to use Algebra 1 to solve that. You're going to add 1 to both sides. And so you have ln 3 plus 1 equals 2x. You're going to divide both sides by 2. And your solution is x is equal to, and if you're going to type this in on a calculator, you want to type it as ln 3 plus 1, and then divide your answer by 2, and that will give you the solution. I'll let you verify that on your calculator. In this example, the logs are in 2 different places, so we need to condense the logs, and the condensing rule we're going to use is the addition condenses to multiplication. So this is going to be log of 2x squared equals negative 2. Now you have to keep in mind that if there's no number written right here underneath the log, that means it's the common log and it actually has a base of 10. So the log is now by itself. Now I'm going to do the convert step. So my base is 10. My exponent is right here, negative 2. So I'm going to take 10 to the negative 2 power equals 2x squared. And so that's 1/100th equals 2x squared. If I divide both sides by 2, I get 1 over 200 equals x squared. I square root both sides, and the square root of 1 over 200 will end up being your solution, and I'll let you evaluate that on a calculator on your own. So we have to isolate the exponential part here, and so we have to isolate in this problem the e to the 5x minus 2. So for this problem, you'd want to isolate the blue piece, which is the exponent. And in order to isolate that, first off, I would start off by subtracting 3 from both sides and dividing by 4. And so when I subtract 3 from both sides, I get e minus 1. So 4 times e to the 5x minus 2 equals e minus 1. And then I would divide both sides by 4. So now I've isolated the exponent. Now I'm going to convert that exponent into a log. This is going to be log base e of e minus 1 over 4 is equal to 5x minus 2. Now you have to remember that this right here is your natural log. And so when I rewrite that, I'm going to add 2 to both sides. So I get 2 plus the natural log of e minus 1 over 4 equals 5x. Divide both sides by 5. That's my solution. If I get out my calculator and I type this into my calculator, I get 0.231. For this problem, the first thing I'm going to do is condense. So when I condense, I take this 2 and I move it up, and so I get ln x squared plus ln 2x, and then I use the addition condenses to multiplication rule. So this is a natural log of 2x cubed equals 4. Now I'm going to convert this, so I have to remember that this ln is really base e. This is e to the 4th is equal to 2x cubed. I divide both sides by 2, so I get e to the 4th over 2 equals x cubed. And now I cube root both sides, and that gives me my solution. And if you evaluate this piece right here on your calculator, I would type it in as parentheses e to the 4th power divided by 2, and then take that whole thing to the 1/3 power. Your solution on the calculator is approximately 3. Lastly, we're going to do a problem that involves a quadratic equation and substitution. You might have to watch this last section a few times before you get the hang of it. We're going to evaluate e to the x plus e to the negative x over 2 equals 3. So if I rewrite this to try to condense the logs, this is e to the x plus 1 over e to the x, because if you look right here, e to the negative x flips over, and I times the 2 up to the 3, and that's equal to 6. And I learned in Algebra 1 that you can't solve problems that have fractions that look like this, so I need to now multiply both sides by e to the x. And so I end up with e to the x times 2 plus 1 equals 6 times e to the x. And if I get this equal to 0, you might notice that it sort of looks like a quadratic. The e to the x is squared. There's a 6 multiplied by the e to the x, and there's a 1. And so now I've got this really strange thing that looks like a quadratic but has e's in it. And so I'm going to look at the blue part and think to myself, well, if it was only simpler, like what it was just m squared minus 6m plus 1, I could deal with that. And so I'm basically stopping right here and letting e to the x equals m, and I start over up here with a much easier problem. And I can solve this problem by completing the square. So I have m squared minus 6m. I move the 1 over. I take 6 divided by 2, I get 9. I add it to both sides. I get m minus 3 squared equals 8. I take the square root of both sides. I get m minus 3 is equal to 2 square root 2. I don't worry about the negative because we can't have a negative as a base for a log. And I end up with m is equal to 3 plus 2 square root 2. So what I have right now is e to the x equals m, and so e to the x is equal to 3 plus 2 square root 2, and I am now starting over again with a problem where my e is condensed to one spot. So now that I've got it down to this, I can convert this to a log. So this is natural log, which you remember is log base e, of 3 plus 2 square root 2 equals x. If I evaluate this on the calculator, I get my solution, and the natural log of 3 plus 2 square root 2 comes out to be 1.76. So you might want to take a look at that previous slide, or just take a look at this idea again. Let's say it had 2 to the 2x minus 3 times 2 to the x plus 2. If you notice that this actually looks like a quadratic, where you have the 2 to the x is squared, and you have 3 times 2 to the x plus 2, and you notice this pattern, and you're like, wouldn't that be nicer if that were something normal, like a w? You could rewrite that as w squared minus 3w plus 2 equals 0, and solve the normal, easy quadratic. This isn't completely easy because it has two possible solutions. But then, since w, like here, is 1, and w represents 2 to the x, I could then solve 2 to the x equals 1, or 2 to the x equals 2, and I end up with two solutions, x is equal to 0, or x is equal to 1. So, like I said, you might want to back up, try that double substitution thing a couple of times. Your homework assignment that we're going to work on in class next week will be on Schoology. Have a good Christmas break.